Okay, so in this lecture, we are going to see more details about nanomaterials, and basically in this lecture we are trying to imagine uh, the size, the nano size, okay, with respect to two approaches. One is a scaling up approach and second is a scaling down approach. So if we start to scaling up approach, if we think about the scaling up approach, then you can imagine if we start to increase from smaller scale to higher scale, then it is called as a scaling up approach. And scaling down means from bigger, if you know some bigger object, and if we start to go reduce the size of that object, then we say that it is a scaling down approach. So as you can see, the nanomaterials are of two types. So let us first remind what is nanomaterial. So material, okay, whose all the three dimensions or at least one of the dimension lies in the range of nanoscale. Okay, that is 1 nanometer to 100 nanometer. Okay, so there are two types of nanomaterials. Okay, one is called as a non-intentionally made nanomaterials, and second is called as an intentionally made nanomaterials. Now, as the word suggests, non-intentionally means we don't have any intention to make that material. We are not doing, there is no human contribution to make the nanomaterials. It means they are already available in the nature. Okay, so non-intentionally nanomaterials refer to nano-sized particles or materials that belong naturally to the environment. They are already present in the environment. Okay, they are made by nature. Okay, so examples are DNA. Okay, butterfly wings. Okay, nasturtium leaf. You can also think about lotus leaf. Okay, gecko's feet. So these are the some of the example, okay, where we have observed this nanoscale effect, okay, which is present in naturally occurred materials. Okay, the second thing is intentionally made. So uh, we have an intention, we have an intention to prepare these nanomaterials in the laboratory, okay, for the various applications. Okay, so nanomaterials um, which are produced deliberately through a defined fabrication process. Okay, so we have pre-decided to make a nanomaterial for some purpose. Okay, for examples is fullerene, carbon nanotubes. The short form is for carbon nanotube is CNT, metal nanoparticles, okay, and ZNO nanorods. So this is some of the very popular nanomaterials which are coming under the category of intentionally made nanomaterial. Okay, so whatever is the application you of nano which you are looking in the your phone, okay, in the memory devices, in the computers, okay, in the hydrophobic coatings, okay, so wherever you are looking the application of nanomaterials, all these materials are coming under the category of intentionally made. Okay, so here is a some sort of distinguish, and as I said in this lecture, basically we are trying to imagine the scale, okay, with respect to the objects or the known materials. Okay, so as far as uh, the scale of the things is concerned, as I said, there are two types of materials. So things which are natural and things which are man-made. So you can see on the screen from on your left side and right side, and in the middle you can see, okay, there is a scale bar. Okay, so the scale, the top of the scale, okay, the upper part of the scale started from the number 1 centimeter, okay, 1 centimeter, and if you are going down to the scale, then you can see that 1 centimeter, then 0.1 millimeter, okay, then 1 micrometer, 0.1 micrometer, point not 1 micrometer, 1 nanometer, and zero point 0.1 nanometer. This is the lowest. Okay, and if you can keep the on the left side of that scale, if you keep the unit constant, that is a meter, then as you can see, uh, the 10 to minus 2 meter, minus 3 meter, and it is going down, down, down up to 10 to minus 9 meter, which is equivalent to 1 nanometer. Okay, and below that it is 10 to minus 10 millimeter, that is zero point 0.1 nanometer. Okay, and if you remember, I already introduced you what is the nanoscale. Okay, so the nano world lies in the nanoscale, and the nanoscale is nothing but 1 nanometer to 100 nanometer. So in this range, we basically uh, have a special world of nano. So we call this as a nano world, okay, from 1 nanometer to 100 nanometer. And if you go above, then from 1 micrometer, okay, to you can say 100 micrometer, okay. So this is a micro world, okay. So basically the material which has the dimension in the micrometer, this is a micro world, and that micro world is not different than the you know uh, the bigger things. So whatever you take, the centimeter, millimeter, okay, centimeter, meter, so all these materials are showing similar properties. Okay, so there is no much change. So you can consider the bigger another word, which is a micrometer word or a macro word. Okay, so if you want to imagine this naturally present things, okay, so you can see ant is in the range of 5 mm, okay, then you can see some fly ash which is in the range of 10 to 20 micrometer. Human hair is in the diameter is of the human hair is in the range of 60 to 120 micrometer depending upon the person. Okay, then red blood cells, okay, is 2 to 5 micrometer. If you go down, and then you can see the DNA is present in the range of 2 to 12 nanometer in diameter. Okay, on the your right hand side, if you see, then the things which are man-made, so you can imagine the macro world. Okay, so head of a pin is lies in the range of 1 to 2 millimeter. Okay, then there are some devices which lies in the range of 10 to 100 micrometer, which is called as a micro electromechanical devices. Okay, and likewise if you see, then you can see some self-assembled nanostructured material. Okay, and you can see carbon nanotube. Okay, so the diameter is in the range of 1.3 nanometer. Okay, the buckyball, okay, carbon buckyball, the diameter is in the range of 1 nanometer. Okay, and if you can see nanotube based electrode. Okay, and in the lowest image you can see the quantum coral of 48 iron atom on copper surface. Okay, so you are basically able to manipulate these iron atoms on the copper surface. Okay, so this is what just for an understanding purpose, that we have both kind of things are available in the nano. Okay, the things which are naturally available, they also have some nano characteristics, nano size. Okay, and the things which are also created by man, okay, by human. Okay, they also have some sort of materials in the nanoscale. So, as I said, again, we are trying to imagine the uh, scale, okay, so in the scaling down process. So, as you see, as you can see, the meter, okay, then decimeter, centimeter, millimeter, micrometer, okay, then nanometer. So is the nanometer is the smallest thing? No. Okay. Below nanometer, there is also picometer, femtometer, attometer. Okay. And if you see the representative objects, then the meter is very well known of you. Many things you can see around you, so which lies in the range of meter. Then decimeter, the size of our palm, okay, hand, okay, the palm. And then the centimeter is the length of a bee, okay, or the diameter of your finger, okay. You can imagine. Millimeter, the thickness of an ordinary paper clip, okay. If you take a paper clip and if you try to measure the thickness, then it comes in the range of millimeter, okay. And you can also find many things, okay, around you. So above, below that, in the micrometer, you can imagine the dust particles, okay. In the nanometer, as I said in the previous slide, in the list of uh, intentionally made materials, you have already seen a buckyball, carbon buckyball, okay. It is also called as a C60 molecule. It is also known as C60 molecule, and the diameter is in the range of 1 nanometer. So below that, is something is present, is something is available? Yes, definitely. So in picometer, that is the radius of an hydrogen atom. It's 23 picometer. Femtometer is the size of a typical nucleus of an atom. Okay, that is a 10 femtometer. Attometer, estimated size of an electron. Okay, so we are interested in nano. Okay, we are not interested in pico, femto, atto. Okay, we are interested in the nano world. Why? We'll see in the next few slides. Okay, again, for with another slide where you are able to again imagine this scaling down process. If you take a dog, so length of the dog is around 1 meter, so that is nothing but 10 raised to 9, 10 raised to 9 nanometer. Okay, if you see a fly, then again, as you see, it is 10 raised to minus 3 meter, okay, or 10 raised to 6 nanometer in length. Red blood cells, you can see it lies in the range of 10 raised to minus 5 meter, or exact. If you want to know the its a diameter, then it is in the range of 6000 nanometer. DNA, the radius is 2.5 nanometer, okay, and the nanoparticle is basically material whose all the three dimensions, or at least one of the dimension, lies in the range of 1 nanometer to 100 nanometer. Okay, again, one more imagination with our known object. So this is a slide where we can see the image, okay, to the left downside you can see an image. This is nothing but the scanning electron microscopic image of a human hair, okay, and you can see a small thing on it, okay, that is nothing but a nano wire of silver, okay, or gold, okay, something like that. Okay, so the two objects are together. One is a naturally present object and second one is the man-made material. Okay, so why I want to show this SEM image is just to visualize how small is the nano with respect to our human hair. So as I said, the size of the human hair may vary from 60 micrometer to 120 micrometer, okay, depending upon the person. Okay, some person has 60-70 nanometer diameter of a hair, okay, or some person may have 100 to 120. Okay, so it depends on a person. Okay, so for simplicity, okay, for our simplicity, let's just imagine on an average, suppose the diameter of a human hair is 100 micrometer, okay, and if we make 100 slices, okay, okay, vertically, okay, if you make the 100 slices of that human hair vertically, then it become once hair human hair get divided into 100 hairs, okay, slices. If you take one slice, then one slice is equivalent to 1 micrometer. And now for that 1 micrometer diameter human hair, if you cut into 1,000 slices, and if you pick up one slice out of these 1,000 slices, then it is equivalent to 1 nanometer. Okay, so if you take a human hair and if you make 10,000 slices vertically, then basically you are able to get one slice which is equivalent to 1 nanometer. Okay, so this is how small we are talking about. Nano, you can imagine, with respect to your human hair. Okay, now another approach is scaling up. Okay, so in the scaling down process, you imagine the big thing, and then we started to reduce the size, and we try to imagine the nano size. Okay, so if you are thinking about the scaling up process, okay, then in the scaling up process, you can imagine something like this. So you have water molecule H2O. Okay, so there are three atoms. Okay, so two hydrogen atom, one oxygen atom, H2O. Okay, so a water molecule is approximately zero point 0.5 nanometer, hmm, is about as big in relation to an apple as an apple is to the planet Earth. Okay, so if you imagine a single molecule of water which is sitting on the surface of apple, okay, so you know you can imagine an apple. Okay, okay, can imagine an apple. Okay, and imagine that one uh, single molecule of water is sitting on the apple. It is very hard to imagine. Okay, it is very hard to imagine. So what we can do, suppose if we keep apple on the surface of the earth, okay, so if we keep the apple on the surface of the earth, then that size of the apple with respect to earth is in the range of nanometer. Okay, so size of the apple with respect to the size of the earth is is in the range of nanometer. Okay, okay, so I think you are get familiar with the things, how small is the nanoscale. Okay, so I think you have got an idea about the nanoscale. So you can now see here how many number of atoms can sit in that scale. Okay, again, scaling up process. Okay, so number of carbon atoms variation with the nanoscale. So basically the Bohr radius of carbon atom is lies in the range of 0.5 to angstrom, that is 0.5 not 5 nanometer. Okay, this is the approximately range of Bohr radius uh, so of the carbon atom. The van der Waals radius of carbon atom is in the range of 0.70 nanometer. Okay, is higher. The van der Waals radius is higher. So for those students who are not aware about the van der Waals radius, here I have shown you the picture. So basically you can see the two atoms, they are coming together, okay, due to van der Waals force of attraction. Okay, but as they are coming close to each other, there is also force of repulsion between the electrons. So because of there is a force of attraction and force of repulsion, there is it get balanced at a certain position. Okay, so when the atoms they get balanced at certain position, okay, then they are settle down at a particular position, and if you start to measure the radius, then that kind of radius is called as a van der Waals radius. Okay, so we are talking about this van der Waals radius in case of carbon atoms. Okay, so now if you have an idea about the carbon atom which have the van der Waals radius is 0.70 nanometer. Okay, so in a 1 nanometer line, three carbon atoms sit together. if you take 3 carbon atoms, okay, and if you take them closer to each other, then they get settled down, okay, together, 3 carbon atoms together, and the equivalent length of the line is 1 nanometer. So in 1 nanometer by 1 nanometer surface, you can see 9 carbon atoms can sit together. And if you take a cube of 1 nanometer by 1 nanometer by 1 nanometer, then you can see 27 carbon atoms, they are they are sitting together. Okay, and in 100 nanometer by 100 nanometer by 100 nanometer cube, then 2.7 into 10 raised to 7 carbon atoms are coming together. So you can see, as we are increasing the size of the nanomaterial from 1 nanometer, okay, to 100 nanometer, then you can see the number of carbon atoms is increasing from in the range of 10 raised to 7, okay, 10 raised to 7 times higher. Okay, so this is what you can think is that we are talking about a scale from 1 nanometer to 100 nanometer, but in that scale the number of atoms becomes very sensitive. Here you can see the classification of substances and materials by their particle, okay, or grain size d, and number of atoms. Okay, so this is a I'm not okay, let me introduce you. So you can also think about a particle size. Okay, particle size, or it is also called as a grain size. Okay, particle size or a grain size. Okay, so if you take a chalk, okay, and if you can see, the chalk is made up of number of particles. Okay, so if you take a single dust which is present on the chalk, okay, which is made up of, so chalk is basically made up of some powder, okay, and if you press this powder in a particular way, then it become a chalk. Okay, so basically it is nothing but powder. Okay, so if you um, take a single particle of that chalk, then you can consider it is a particle or grain. Okay, so what is the size of that grain? Okay, and how many number of atoms are present? Okay, so in the last slide we imagine at the nanoscale, if the size is 1 nanometer by 1 nanometer by 1 nanometer is the size of the cube, then the number of atoms is 27. Okay, but if the same cube has now size is 100 nanometer by 100 nanometer by 100 nanometer, then its number of atoms just got increased by 10 to 7 times higher. Okay, so a similar thing you can imagine here. If the size of the particle is in the range of 10 micrometer to around 0.1 micrometer, then the number of atoms lies in the range of 10 to 8 to 10 to 9. Okay, these are the number of atoms which are available in a single particle. Okay, we are talking about a single particle. Okay, if the size of the single particle is in the range of 10 nanometer to 100 nanometer, then you can see that still a large number of atoms are available, where it is in the range of 10 to 6 to 10 to 7 times. Okay, 10 to 6 to 10 to 7 atoms are available when the size of the particle is 10 nanometer to 100 nanometer. If the size of the particle is in the range of 1 nanometer to 10 nanometer, then you can see from several tens, 20 to 70, okay, atoms are available, or at the max 500 to 1500 atoms are available. It depends upon the size of the particle. Okay, and below 1 nanometer, you can see the number of atoms are going down. So below 1 nanometer, basically the molecular clusters or atoms, okay, atomic world started. So we are not dealing with the atomic world or nuclear world. Okay, we are interested in the nano world. So our world lies in the range of 1 nanometer to 10 nanometer. So definitely this is a size, okay, with which we have tried to imagine the objects, but how to measure, how someone has measured this size. Okay, so some of the techniques are uh, needed where you need very high uh, magnification power. Okay, so here you can see that human height and most of the bigger objects which lies um, in the range of meter to centimeter to millimeter. Okay, mostly we are able to see this by human eye. Okay, below 100 micrometer we have to use some optical microscopes. Okay, up to 10 micrometer we are able to use the optical microscope. Below 1 micrometer, okay, below 1 micrometer we have to use a special microscope which is called as an electron microscope. So optical microscope is basically a microscope where we are using light, okay, to see the object, okay, in the transmission or reflection mode. But in the electron microscope, instead of light, we are using the electron beam to see the objects, okay, so which are much smaller in size, but the electron microscope is able to see the size of these objects. Okay, so this is what some special observation tool or technique is used to see different objects which are lying in the different size. Okay. This is again a very beautiful example where you right now it is happening with you. Okay, so right now in the nano world something is growing naturally with you. Okay, so you can see on the left there are two photos. Okay, one is on the left side, one a finger, some ladies is showing a finger, okay, and some nail polish is trying to deposit on the nail. Okay, so you can see a human fingernail grows 1 nanometer every second. Okay, so you can now imagine, okay, in each second right now your nail is growing with the rate of 1 nanometer. So what is the growth rate of your nail? 1 nanometer per second. So in each second your nail is growing with the size of 1 nanometer. Okay, on the right side you can see a man, okay, which has a very beautiful braid. Okay, so the man's braid grows 5 nanometer every second. Okay, so you can see our hairs, okay, hair or the braid. Okay, so this is right now it is growing with the rate of 5 nanometer, okay, per second. Okay, so this is what because we are not able to see the scale. Okay, it is so small. Okay, but it is working. Something is working at the scale right now in front of us, but we are not able to see it because our we don't have that much of power in our eyes. Okay, magnification or the power of eye is not that we don't have that power to see that objects which are growing right now. Okay, so for that we need some special techniques as I already discussed. Okay, so this is a very interesting thing that something is growing right now in front of you, okay, in the nano world, but that world is different than our macro world. So uh, we are just imagining that something is happening there, but if you want to exactly see it, then you need some special technique to observe it. Okay, so thank you. We'll stop here.